So hello everyone, myself Rohit. In the last previous video, we have learned about the data pre-processing techniques and uh, various data set about that we are using the Pylearn to the MNSIT data set, the CIFR data set. In the current video, I have taken a code sample that we use using the Pylearn to for the Pylearn. So first, standard library we are importing. So import OS about the SYS and a time, then import NumPy, the numerical Python, and SkyPy, the Theano. Because example that is the Theano, the top of the Theano NumPy is import argmax, argument max and a tensor. So it's all about the how we train a model, how a training and testing is done using a Pylearn tool. So basically, the first if we talk about the first things are there that okay, we use it as called a Pylearn exceptions class and a Pylearn error, and in we catch exceptions is there. Okay, we catch the exception and then the path provide a pass and the class storage example that is all top level classes inherited from the object. In this object it is inherited. So they basically the first class that is a Pylearn error that is basically used to catch exception, and then in the next level class that is storage example in which inherited the object things at top level. To sync blank line identification or top level classes and the functions, and definition of the initialization of the class in which the print the field and the self. The two parameters are passed in which the awesome learner means the simply we will define later the definition of train, definition of add field. These are the classes of the function and definition of testing error. These things are there. If none, main print subtract there. So okay. So if we talk about the basically things that okay, um, the two blank lines between the definition, the top level classes and the functions. So awesome the class of awesome learner, basically the learner about the learner, learning things are and write a document to write a document and things like that. So super class and the super class is awesome learner and the self. The self is the same thing. The self is called and the initialization classes that define the previously things are the initialization things are there, definition initialization that the function is called, and a self dot print field if nothing is none is printed, we kind of printed that. Okay, next function definition of add field. So add field means that okay, the container specific method like indexing is there, so this type of method, and if the field in the self print field, so it's provide a pass to this. There is a definition of training function. This is a very important things are there in this slide set in the data set, any data set that in they say IST or the CIFDR data set is passed, and the count number of self and the main fields, the mean or the mean field, the count initially is no good thing is count. So for sample dictionary, the sample dictionary means you can say for the sample dictionary that is a self or data set, and then the data set you will check the data set whether it's enough for what you need or interactive or which things are there. So for field the value in the sample dictionary it returns so to keep the okay maximum 80 character or something for intense houses. So that's same thing as a count count dot get field. That's when counting is there's a loop. The loop is incremented in this, and same thing is there. Then testing is the field or the self in the print field. So print field the what you have to print the final. And definition is a test error function in which a data set is passed, and some self means the same parameter that's the starting base of self is passed in that. So the testing, this is a training function, the complete train of data set training, the testing error. Uh, If not has at error the sum of the field, then there is a Pylearn error, and they cannot be a learner that were not trained. So training is that error is if initially is error is zero and counting is zero to for the simple dictionary in the dataset which you try to minimize the code and try a statement and then mean find a mean and self dot mean field what is the mean of this field and then the exception and raise a Pylearn error. Okay, found it test simple is the field is or something like that. So it's raise the Pylearn error and try catch block. Try except raise block. As same in the try catch block in the Java. So it's a basically coding example how we are using in the Pylearn to some basic library, Piano or something like that. Piano and SkyPy, NumPy, argument tensor, these things, how the import formula, the Pylearn formula import noise and data set learner, what is the, from Pylearn import data set, things are learner that use basically that learner class or awesome learner, so learner top learner, that basically are the data set itself, things are training, the testing error, the function, and if it's none, then return okay with a variable filter. Basically print subscribers in the dictionary directory in which in the shorted form. So the subdirectories are shorted and check in the loops condition and print the directory and the main function. Okay, length was the conventions is how to display the script documentation and the argument till the v is determined that's the wave and the print finally the print the which dictionary and the subdictionary which containing these arguments and finally the data function. So this is a layman code using the find Pylearn tool. We can deeply describely explain a function in Pylearn 2. So basically, if you talk about the Pylearn 2, the great things I know about Pylearn 2, the first thing is there. It's allowed to you maximum, it allowed you to experiment new ideas without much implementation overhead. And the library was built to be modular. The modular libraries are built and aims to be unusable without the extension knowledge of the code base. So if you're writing a new model from the scratch using the Pylearn tool, so the first thing is do that. Okay, what we have to do and because what we have to look basically. And the second things are there that it has the interface YML that allows to use and decouple implementation from the experimental choices. So I think decoupling things, decouple implementation means that okay, it has a interfacing .yml file that from the experimental choices, it basically tells about that what choices we have enabling the experimental things and the experiment to be constructed in the lighter readable fashions. So the top level execution calling the main function. If we talk about the basically the definitions or means about the and this dictionary, the convention, how to display the script documentation and using the list comprehension rather than the filter or the looping things in there, the definition of the training function and counting error minimization to try the adjustment block. So it's similar as in programming languages, but yes, some import using the Python things are there, other different things are how to implement a trainer model. So basically, if you train a model, if you train a new model using the Pylearn tool and the training, so we can train an example. So training is basically example we can standard about the GRBM SMD. So train ARBM with a Gaussian unit. We train about this and using the CIFAR dataset. So basically, the if we talk about the CIFR dataset and if we talk about the CIFR dataset, so CIFR dataset it has the basically about the 60,000 images in which the 10,000 for the training purpose and the 50,000 for the testing. 50,000 for training purpose and 10,000 for testing. So the first thing when we learn a model or train a model using your Pylearn tool, so first to download the CIFR dataset. It evaluates two methods for downloading the CIF dataset. First, that okay, it's basically a Python .py file that is available on the GitHub. So how to make or how to download the CIF dataset, and a separate Python file is available on the GitHub that is used to find the exact say exact CIF dataset that is available on this 160 or 70 MB data there. Then train the model and finally then expect the final model about it. So basically three things are there to train a model using Pylearn 2, and it's all about the CIF dataset that it is using in the Pylearn using the Pylearn. So the great things are there about the Pylearn 2, the interfaces, the YML file, the decouple implementations, things are there, and it's a living code. In the next slide, we will tell you about the exact things are there, how we write a code in the using the GitHub, and the testing error or something, a train or something or there are some learner, and these important things are there, the absolute path, the error exception handling, and training a data set. And basically a data set I use in like Pylearn to CIFAR or MNIST data set. So the finally things that we learned from this video, that okay, if we are using I'm using the Pylearn 2, then these three things are there from the data set and train and inspect the model. These are basic things in every machine learning algorithm. The things are there, okay, when you new model from the scratch, then we have to do the what we have to look. That's the basic important things. And in the next video, we will take an example of exactly say software the max software regression problem that we are going to take that how the Pylearn 2 things are working on this, and how the Pylearn 2 things are basically finding of this. So in the next video, we will tell you about the implementation, practical implementation of the Pylearn. Thank you all.